Okay, what we're doing here is we're going to be going through the answers, the solutions to Test 4 for Math 140 and Test 5 for Math 110. They are, both tests had 20 questions and they're from exactly the same test bank except for the last question, question number 20. So this will be a video that both Math 140 and Math 110 students can watch. So let's come over here. So the first 19 questions will be the same for everybody. Okay. So if we're going to use an augmented matrix to solve this system, then what I'm going to have to do is to, actually I'll do it. Okay, so let me move this over here. Okay, that's good. Okay, so I need to define this augmented matrix. So I go to the matrix menu, and it's going to be 3 rows and 4 columns. And this first row tells me I'm going to have entries -2, then -4, then +4, then 14. And the second row tells me my entries are going to be, so the coefficients there, 4, 2, 4, and -4. And then finally, I'm going to have 1 times x. Then there's no y term, so the y coefficient is 0. And 2 times z, so, and then I have equals -2. And the last thing I'm going to do before I get out of here is I'm going to recheck, and I'll do it by the columns. So the last column should be -2, -4, 14. Then that column for the z coordinates are going to be, coefficients are going to be 4, 4, and 2. Column for the y coordinates going from bottom to top would be 0, 2, and -4. And then the column for the x coefficients will be the first column. From top to bottom is -2, 4, and 1. So I'm happy that that's correct. So I'm going to get out of this second mode and I'm going to get back in. Then I'm going to go to math, and I can get to RREF quicker if I scroll up. And then I'm going to get back into the matrix menu, and under names I'm just going to select A, and then I'm going to put that parenthesis there. And so this is what's happening. And so that's where my equal line is, and my first row tells me 1 times x plus 0 times y plus 2 times z equals 0. Actually, I can do this quicker with okay, let me just, all right, so this tells me, so I've got, actually I'll just copy it here. Okay, so there's my equal sign. There's my column for x, y, and z. And so this first row tells me 1 times x plus 0 times y plus 2 times z equals 0. This tells me 1 times y minus 2 times z equals 0. And this tells me 0 times x plus 0 times y plus 0 times z equals 1. That is a contradiction, a false statement, and so there is no solution. So now if I come back here, it said if there is no solution, input the empty set. And you have to use curly brackets and not parentheses or square brackets for the empty set. Okay, so I'm going to input the empty set there. All right, and again, if possible, solve this using an augmented matrix. So it's going to be the same thing. I'm going to get back into the matrix menu. I'm going to go to the editor, and again, this augmented matrix will be a 3 by 4, and row by row. First row, my coefficient is going to be 2, 5, 1, negative 12. Second row, my coefficients will be negative 1, 4, 3, negative 4. And for my third row, I'm going to get 5 times x, so a 5. Then there's no y term, so it's 0 times y. And then negative 2 times z, and then negative 13. And before I do anything else, I'm going to check the last row, bottom to top. Yep. Then that third column, my coefficients for z are 1, 3, and negative 2. Then for the y column, bottom to top, I should have 0, 4, and 5. And then the x coefficient column, I should have 2, negative 1, and 5. So I'm satisfied that that's okay. So second mode, get out, get back in, go to math, scroll up to RREF, get back in. Under names, just press enter for A, and then close off that parenthesis. And now I get this. So now my row reduced echelon form gives me this. Okay, so again, that's my column for x coefficients, y, and z. So the first column tells me that x is equal to negative 3. The second column tells me y is equal to negative 1. And the third column tells me z is equal to negative 1. Okay, so I have a unique solution. And what do the directions say? If there is a unique solution, write it as a point in 3-dimensional space. Do not use any extra spaces. And here's an example. Coordinates are written with parentheses, and I had some people use curly brackets. So I guess they read this here for the empty set, saying you had to use curly brackets for the empty set, and thought you had to use curly brackets for everything. I mean, there's a clear example there. You write points with parentheses, coordinates with parentheses. So my answer here is a single point in 3-dimensional space, and it's going to be negative 3, negative 1, negative 1. So negative 3, comma, negative 1, comma, negative 1. And I have not had any spaces in there. So I didn't use any extra spaces. So that's what I say the answer is. Okay, so what about this guy? We're going to do the same thing. Going to get into my matrix menu, go to the editor. Again, my augmented matrix will be a 3 by 4, and the first row, according to this equation, is going to be 3, 2, negative 3, 13. The second row is going to be 4 times x, so I'll have a 4. Then there's no y term, so it's 0 times y, and then 4 for my z coefficient, and then 12. And the third row is going to be negative 2, negative 1, 1, and negative 8. And the last thing I'm going to do is I'm going to check that these are correct. So to the right of the equal sign is correct. My coefficients for z are correct. What about my coefficients for y? Negative 1, 0, and 2. And then my coefficients for x should be, if I look at the column, 3, 4, and negative 2. So I'm happy that's correct. I haven't made a mistake. I'm going to get out, going to get back in, scroll over to math, and scroll up to RREF, and then get back into the matrix menu, and under names, just press enter. You want A, and then close off the parenthesis, and it gives me this. And so I've got this for my augmented matrix. So what I've got here now is the first row tells me 1 times x plus 0 times y plus 1 times z equals 3. The second row tells me 0 times x plus 1 times y minus 3 times z equals 2. And the third row tells me 0 equals 0. This is a true statement, nothing cancel. That tells me that there are infinitely many solutions. And so the instructions for infinitely many solutions say, if there are infinitely many solutions, write the general solution with respect to the letter z. Okay, so I have to write a point in three-dimensional space, but I can only do it with one letter, z. So I'm going to keep the z, and I've just got to figure out what do I write instead of x and what do I write instead of y, and that's where we go back to these equations. So if I subtract z from both sides, x is equal to negative z plus 3 or 3 minus z. So I'm going to put a 3 minus z in there. And then what do I get for y? Well, I go to this equation and I add 3z to both sides, and that tells me y equals 2 plus 3z. So I'd have 2 plus 3z here. And I need to enter that as my answer. So it says, if there are infinite many solutions, write the general solution with respect to z. Do not use any extra spaces. Okay, so I'm going to have 3 minus z, comma, and we have to use parentheses. It's a point. So we don't use curly brackets. Curly brackets are used for sets. And so that's why with the empty set, you have to use curly brackets. Okay, so that's what I'm going to give as my answer to that one. All right, graph the solution to the system of inequalities. Okay, well, if I'm going to do this and put it in my calculator, then I'm going to have to get y by itself. Okay, so to do that, all right, so if I subtract 2x from both sides, it does not change the direction of the arrow. If I divide everything by negative 2, it does change the direction of the arrow. So I'm going to have y is less than or equal to, 4 divided by negative 2 is negative 2, and the negative 2's cancel here, and I'll have plus x. Okay, so I'm going to look at that first. Clear this out. So negative 2 plus x. And let's just do a zoom 6. Okay, so I want the line and everything below. Okay, and now let's get the second region. If I subtract 5x from both sides, it does not change the direction of the arrow. Okay, so now let me put this in 10 minus 5x and do a zoom 6. So there's my first line, and there's my second line. And because of the symbol here, we want everything on this line and below. Now the answer here is where we have our pattern overlap. So this is the region that I'm looking for, this shaded region right here. So if I go back to the question now, okay, then my answer is going to be this one here. Okay, so that matches the shaded region, the overlap. So I'm going to give my answer as A. I'll put it in the way they have put it in here. If you left off the parentheses or gave a capital letter, that was fine. It accepted it. Okay. For the given graph above, find the maximum value of the objective function. Z is equal to 3 minus 2y. Okay. All right. So we want the maximum. Okay, so first of all, what are our corner points? What are our vertices? And I can see this point here has coordinates 4, 2. Then going clockwise, this point has coordinates 7, 9. This point has coordinates 12, 11. And this point has coordinates 7, 4. And my objective function is z equals 3x minus 2y. Now, what are you asked for? You are asked for the maximum value. It said that in bold letters, and then right here it said only give the maximum value and nothing else. I had a lot of people that gave the coordinates, one of the corner points. That is clearly not what was asked for. Okay, so we are looking for the maximum value. So what happens there? I plug in 4 for x and 2 for y. So that's going to be 12 minus 4, which is 8. And now what happens if I plug in x for 7 and 9 for y into this equation? So that's going to be 21 minus 18, and that's going to be equal to 3. Okay, so what if I have 12 for x and 11 for y? 3 times 12 is 36, minus 22. Okay. And then I've got that. And I'll have 3 times 7 minus 2 times 4. So I'll get 21 minus 8. And I'll get 13. Okay, so it looks very much like that is my maximum. And if I'd been asked for the minimum, that would have been my answer. But I've been asked for the maximum, so I think it's 14. Okay, now for the given graphic above, now we are to find the minimum value. Okay, all right. So for the minimum value, what are my points, my corner points? So I'm going to start here. That's 8, 1. And then I've got 5, 8. And then I've got 7, 11. And then I've got 12, 5. And the objective function here is 2x minus 3y. And we need to know the minimum. Okay. If x is 8 and y is 1, I get 2 times 8 minus 3 times 1. So I'm going to get 16 minus 3, which will give me 13. Okay. What happens here? Well, 5 is x and 8 will be y. So I'll have 2 times 5 minus 3 times 8. So I'm going to get 10 minus 24, which should be negative 14. And then I have 7, 11. So I have 2 times 7 minus 3 times 11. 14 minus 33. That will give me negative 19. And then I've got 12, 5. So I'll have 2 times 12 minus 3 times 5, which is 24 minus 15. And so that should be 9. Now here they want to know the minimum. So that's going to be my minimum. My maximum would have been 13, but my minimum here is negative 19. So it says only give the minimum value and nothing else. Okay. Solve this system of equations using substitution. Okay. So I've got x squared plus y squared equals 169. And then I have x plus y equals 17. So I can't stack these because they don't have the same power. Okay. I might subtract x from both sides of this, and I get y equals 17 minus x. And then I'm going to substitute that into this equation. So this equation will become x squared plus y squared, which is 17 minus x all squared, equals 169. So I'll have x squared plus 17 minus x times 17 minus x is 169. And that's going to give me x squared plus 17 times 17 is 289. Minus 17x minus 17x, so minus 34x, and then plus x squared equals that. So here I'm going to have 2x squared minus 34x, and then plus 289 minus 169. So if I subtract 169 from both sides, 289 minus 169 is 120. And notice that all of these are divisible by 2. So if I divide everything by 2, I get x squared minus 17x plus 60. And 0 divided by 2 is fine. It's legal. It works. It's 0. And now I can try and group this. Okay, so 60. I could have 6 times 10, but so negative 6 times negative 10, but when I add those up, I get negative 16, so it's not quite there. What else could I have? 60 divided by 5 is 12. Okay, so I could have negative 12 and negative 5. So when I multiply those two, I get positive 60, and when I add negative 12 and negative 5, I get negative 17. So my solutions here are x is 12 and x is 5. So what happens if I've got x is 12 and x is 5? Well, if x is 12, then y is 17 minus 12, and y is going to be 5. So I have an intersection point, a solution, 12, 5. If x is 5, then y will be 17 minus 5, and y will be 12. So I get another solution, 5, 12. So I get 12, 5 and 5, 12. And that looks like that one. Okay, given a graph, identify the system of equations. Okay. Well, how can we do that? I can see that the intersection point is negative 3, 1. So negative 3, 1 should work in both equations. But negative 3 is positive 6 and comma 1. So if I get positive 6 minus 7, and so that does not work here. So I can see what I'm trying to do here. All right, so that's an intersection point. And that's negative 3, comma, positive 1. And since it's an intersection point, it has to be true for both formulas. So if I plug it into both formulas, it should work. Now with this, if I come to a formula and it doesn't work, I can automatically rule it out. So this would be -2 times -3, which would be +6, minus 7 times 1. And that would equal -1. But here it says it equals -9. And so because of that, there's no way it can be that one. All right, what about here? -3, +1. So I would have +6 plus 3, and that works. So I don't know yet, but it's still in the running. And here, -3, so that'd be -12 plus 7. So -12 plus 7 would be -5, so that works there. So far that's in the running. Here I would have +3. I'd have +6 plus 7. So -2 times -3. So I'm plugging in the -3 for x is +6, and then plus 7 times 1. And that does not equal 9. 6 plus 7 does not equal 9, so it cannot be C. So I've ruled a couple of things out. Now what about this one? -2 times -3 is +6. Then minus 3 times 1. And that's 6 minus 3, and that does not equal 9. So if I look at that intersection point, that's the only one it could be. So I think it's going to be B. And I'll enter it in the way it was here, but if I leave off the parentheses, it should still be okay. Write a system of linear inequalities that has this given graph. Okay, this is the line y equals 3. And from this region here, I'm going to have y is on the line and above. So I am going to need y is greater than or equal to 3. I'm going to have that in my system. All right, so this line is y equals 3. Okay, this line here is y equals 3, that horizontal line. And so for this region to be there, one of my equations is going to have to be on this line and above. So I must have y greater than or equal to 3 in as one of my selections. Okay, it's in that one. It's not here. I get the wrong one here, so it's not going to be that one. And that's the wrong one, so it's not going to be that one. And I do have it in there. Okay, so that's good. All right. This is the line. This diagonal line here is the line y equals x. It's a perfect diagonal and it goes through the origin. Okay. And if I'm going to have this region, then one of my equations is going to have to be on this line and below the line. So I'm going to need y is less than or equal to x. Okay. So that would be this line and everything below, if it's going to be in that shaded region. And the horizontal line, y equals 3, and everything above, if I'm going to have overlap in that triangular region. So I'm going to need those in the running. And that is not correct. I need the y is less than or equal to x. And so that is not correct. And so that's out of the running. So now it can only be the last one. I'm going to pick that one. Okay, a person with no more than $4,000 to invest plans to place the money in two investments, telecommunication and pharmaceuticals. Okay, so what I'm going to do is I'm going to let X be telecommunications because it mentioned it first, and Y is going to be pharmaceuticals because that was mentioned second. I'm trying to write with a mouse and it's not easy at all. Okay. Write a system of inequalities to describe the situation. So X is going to be how much you invest in telecommunications, and Y is going to be how much you invest in pharmaceuticals. A person with no more than $4,000 to invest. So you have to make an inequality out of that. So the money I have for telecommunication plus the money I have for pharmaceuticals cannot be more than $4,000. So that's your job, is to take the words and get an algebraic expression. So that cannot happen because that has equal. That's good. That cannot happen. And that's good. So we've ruled this one out and this one out. Okay. Now, the money that you invest in telecommunications has to be a positive number. You can't invest negative numbers, and the same negative dollars, and the same for the money that you invest in pharmaceuticals. So we would need X is greater than or equal to 0, and we would need Y is greater than or equal to 0. Okay, and that has not whittled anything down. Okay, so it's going to come down to this. The telecommunications investment. Okay, so the telecommunication investment, that's X, is to be no more than 3 times the pharmaceutical investment. So that's 3 times Y. So X is to be no more than 3 times Y. Okay. So that's what I need, and that's what we have here, and that's not what we have there. So that's X less than or equal to 3Y. Okay, so out of all of those, it's going to be the second one. Okay. All right, suppose we have this matrix. What is the entry that lives in row 3 and column 1? So matrices are represented by capital letters. If you had been coming to the Zoom sessions, we talked about this at length. So the matrix is capital N, so lowercase m is the entry that lives in row 3 and column 1. So it's the row first, followed by the column. Row 3, oops, sorry. And I'll have to erase row 3 and column 1. Okay, so row 3. And column 1. And there's only going to be one entry that lives in both of it, and it's 32. The answer is 32. All right, suppose we have this matrix. If the matrix M is negative 5A, what is the entry in the third row and first column of that? Okay, so my matrix M is going to be negative 5 times the matrix A. And if you multiply a matrix by a scalar, then that number gets multiplied into every entry. So -5 times 2 is -10. -5 times -10 is +50. -5 times 11 is -55. -5 times -1 is +5. -5 times 14 is -70. -5 times -2x is +10x. -5 times -4y is +20y. -5 times -3z is +15z. And -5 times 31 is going to be -155. So here is my matrix M, and now we've been asked what is the entry in capital M that lives in row 3 and column 1. And it's going to be 20y. That is the answer. So that's what I'm going to write. Okay. All right. So here, M is equal to A times B. All right. Now, what is A? A is an 11 by 7. And what is B? B is a 22 by 11. Now, when I multiply these two, I look at the inside numbers, and the inside numbers do not match. And so the matrix M is not defined. And so what did the instructions say to do? If M does not exist, then input D and E as your answer. It would have also accepted D and E in lowercase. All right, so now let's look at the next question. All right. M is equal to B times A. Okay, and what do they say B is? B is a 22 by 7, and A is a 7 by 11. I look at the inside numbers, and they're the same, so this will exist. Now, what kind of matrix will it be? It'll be a 22 by 11. So the dimensions of M are 22 by 11. And the only thing that we're supposed to write are the dimensions, 22 by 11. And use the lowercase x. So that's all we're to put in there. Okay, now let's consider this. All right, let me do this in really. So I'm going to have C times B minus 5 times D. Okay, now what have we been told about D? D is a 7 by 5, and so 5 times a 7 by 5 will also be a 7 by 5. Multiplying a number by a matrix, a scalar multiplication, does not change the dimensions. So 5 times D will also be a 7 by 5. Now what about the matrix B? We've been told that B is a 7 by 5. Now, you can add or subtract two matrices if they are the same dimension, and they are. So these inner parentheses will work, and we'll get a 7 by 5. Now, what about C? C is a 5 by 7. So when I get down to here, the inside numbers are the same. This will work. It is defined. And what do I get? The numbers on the outside. So it is defined, and I will get a 5 by 5. And so I'm going to put 5 by 5 in here. 5x5. Okay, let's see what this is. I have got A times B minus 5 times C. Okay. What is C? C is a 5 by 7, so if I just multiply it by a scalar, it's still a 5 by 7. What about B? B is a 7 by 5. I cannot add two matrices unless they're exactly the same dimension. If you add or subtract matrices, they must be the same dimension. I could multiply these, but we're not multiplying, we're subtracting. And so this does not exist. So the whole thing does not exist. Okay. All right. For here, we need to know what x is. And we only want the answer, and it specifically says do not write x equals as part of your input. Okay. So let's look at this. Okay, now we've been asked for x. So what I'm going to do is I'm going to underline the equations that have x in them. So that gives me an equation that I'm going to write in blue. X, let me go to a bigger size here. X plus 2 equals 2x plus 6. Okay, how about I subtract x from both sides? So 2x minus x is x. And now how about I subtract 6 from both sides? And so I get negative 4 is equal to x. Okay. Now, are there any other equations that have x in it? Yes, they are. And this is how I can check. So that has an x in it, and it's going to have to be exactly the same. If these two matrices are equal, they have to have the same dimension and they have to have the same entries. And so I have to have that 2x is equal to negative 8. And we can see if x is negative 4, that definitely satisfied. So I don't have anything else with x, and I was only asked for x. So x is negative 4, and it just says only give the answer. Do not include x equals as part of your input. Okay. All right. Now, m is a product here. And a lot of you put that m of 3, 1 is that, which is not correct. M is not this matrix. M is this matrix times that matrix. So we have to know how to do matrix multiplication. And you can't put this into a graphing calculator. So again, I might try and do it with this. Okay. This is a 3 by 3. And this is a 3 by 1. And so this will work because the inside numbers are the same, and we'll get a 3 by 1. Okay. So let me change color. So I'll get a 3 by 1. I'll have 3 rows and 1 column. Okay, what am I going to get in here? Well, where does that live? Row 1, column 1. So to get that, I'm going to have to do a row 1 times column 1. And that's going to be 1 times x plus negative 2 times y. And then plus negative 3 times z. Then this is row 2, column 1. And that's going to be row 2 of this times column 1 of that. And I'm going to have negative 4 times x plus 5y minus 6z. And finally, where does this live? Row 3, column 1. So I need row 3 of this one and column 1 of this one, and that'll give me 7 times x minus 8 times y minus 9 times z. Now, what is this asking us for? This is M. That's my matrix M. And what is the row, the entry that lives in the third row and first column? So that's going to be what's in green. So we're going to have 7x minus 8y minus 9z. 7x, whoops, I got it all caps on, minus 8y minus 9z. Okay, so So 3, 1, row 3 of the first one, column 1 of the second one. 7 times x plus negative 8 times y, which is minus 8y, plus negative 9 times z, which is minus 9z. No extra spaces. Okay, so no spaces in there. All right. Compute the inverse of the matrix. Okay, well, I just need to put that into my calculator and get it to tell me. So let me get that in there. Okay, so I need to get into the matrix menu, go to the editor. I'll call it A. This is a 3 by 3. And so I'll have negative 4, negative 3, 3, negative 4, negative 1, 4, negative 5, negative 3, and 4. Enter. Now, before I do anything else, check that you have entered the correct matrix and do it by column. So the third column going down up is 4, 4, 3. Okay. The second column going down from top to bottom is negative 3, negative 1, negative 3. And the first column going from bottom to top is negative 4, negative 5, negative 4, negative 4. Okay. That's all right. So I'm going to get out and I'm going to get back in. And under names, I'm just going to press enter for A. And then I'm going to press the X inverse symbol and I'm going to press enter. All right, so according to my calculator, A inverse is the matrix 8, 3, negative 9, negative 4, negative 1, 4, 7, 3, negative 8. And now that's what I need to match. So selection A, nope, selection A doesn't work because it's got a 0 in the middle. What about selection B? Nope, because it's got the wrong entry in that bottom corner. Okay. All right, what about entry C? 8, 3, negative 9, 4. Nope. And so by default, it's got to be D, but I'll just check it. 8, 3, negative 9, negative 4, negative 1, 4, 7, 3, negative 8. It is, the correct answer is D. So I'm going to enter it the way it's entered there. But again, if I left off the parentheses or used a lowercase, it would have been accepted. Okay, now, if you're in Math 140, this was your question 20. Okay, so if you're in Math 140, this is your question 20. So we have these matrices. And I'm going to call that capital B. And so we have A times X equals B. And what is the matrix capital X? Well, as we saw from our lessons, it's always going to be that. But we want to solve for X. So we want to find X. Now, we've been told A inverse exists, and so that's really all we need. We know A inverse exists, so what I'm going to do is I'm going to multiply the left-hand side by A inverse, and you have to multiply it on the left-hand side here. If you do B times A inverse, it won't exist, and then you're going to go straight to the wrong answer. So when I do that, these will cancel out. And that's what I'm going to have. So if I'm going to use my graphing calculator, I'm going to define A and B. And then have it do A inverse times B. So I'm not going to use that in my graphing calculator. Okay, so I'm going to define A and B as they are. Okay, going to get into the matrix menu, and let's start with A. It's a 3 by 3, and I had to be very careful. I have negative 187, then I've got 69, then we have negative 10, then we have 112, then we have negative 41, and then we've got 6, and then we have 19, and then we've got negative 7 and 1. And I am going to definitely double check this before I do anything else. Okay, looking good. I'm going to get out. I'm going to get back in. I'm going to go to the editor, and I'm going to scroll down to B. B has 3 rows and 1 column, so it's a 3 by 1. And what we have is going to be negative 5, 1, and negative 8. I need to get out. I need to get back in. And under names, I'm going to select A, and then it's going to be A inverse times B. And then times, and then get back into the matrix menu, scroll down to B, and press enter. And so that's going to be what I look for, and I can see that that matches with selection A. So my answer here is A. Okay, now that's it for Math 140. For you Math 110, your question 20 was like this one. So your question 20 was like this one. So for Math 110, so this is Math 110. This was your question 20. This is from the bank for your question 20. All right, so it's the same thing. You have to know how to be able to do this. How do you do this matrix multiplication? I have a 3 by 3 times a 3 by 1. I'll get a 3 by 1. So that's going to equal, that won't change. Okay, where does this live? It lives in row 1, column 1. So I'm going to take row 1 of this and multiply it by column 1 of that. 2 times x plus 3 times y plus 1 times z. 2x plus 3y plus z. So where does this live? Row 2, column 1. So I'm going to take row 2 of this and multiply it by column 1 of that. 6 times x plus 3 times y plus 4 times z. And finally, that lives in row 3, column 1. So I'm going to take row 3 of this and multiply it by that column. So 2 times x plus 0 times y, so that's 0, minus 1 times z. So for these two matrices to equal each other, they have to be the same dimension. They're both 3 by 1s, and each corresponding entry must be the same. So my first equation that I get should be this entry, row 1, column 1, is the same as this row entry. So I should be getting the red, what I circled in red, equal to each other. And that happens everywhere. So I haven't eliminated any of them yet. Okay, what about the second one? So the entry in row 2, column 1 here has to be the same as the entry in row 2, column 1 here. So 6x plus 3y plus 4z equals -1. And so far that's happening everywhere. And then finally, row 3, column 1 of this one has to be the same as row 3, column 1 of that one. So 2x minus z equals 2. That is not correct. 2x minus z, that one's not correct. 2x minus z, that's not correct. So by default, it's going to be D. 2x minus z equals 2. So my answer here will be D. And so that's what you would have filled in for that one. Okay, so that ends the test for both courses. So they came from the same test bank except for the last question. So this one I just went through was in the Math 110 test bank. So that concludes this.